Alrighty, welcome everyone to day 3 of Adventure Code. Day 1 was a bit rough, but yesterday we got more back on track in terms of solving them and not getting tripped up as much, but here's hoping day 3 goes even better than the past 2. Question releases here in just a few seconds. My code is all set up. Let's get to it in 3, 2, 1, let's do it. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They are not moving. You turn around and see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while if I can fix it. You offer to help. The engineer explains that the engine part seems to be missing from the engine, but nobody can figure out which one. Or figure out, yeah. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods are not as... Okay. 2 numbers are not part numbers because they are not adjacent to a symbol. 114 top right. Okay. What's the sum of all part numbers in the engine schematic? Lovely. Okay, so I think this should be as simple as just going through and looking for every symbol, and then every symbol you just get all the adjacent numbers. Oh no, but it's because it's diagonal. Okay. Okay. I see. So we're gonna start off by just having our map you know what? Let's do this. Let's do a bit differently. We're going to do input, and we're going to simply split on new lines. And then we're going to map, it's a sum, they said. Sum of all part numbers. Okay. So we're going to map, and this is going to be a line, and then for each line, we're then going to split on each character. And then for each character, we're also going to go through. So when... Actually, we're going to reduce. We're going to call it reduce. Sum, this is the line, start at 0, more reducing because we're again summing, line sum, and C, start at 0, we're just going to return sum for now, return line sum. So for each character, what we're going to do is we're going to say if, what are all the characters? I guess we're going to do C. And C is greater than 9, or C is less than 0. I believe it's 0 first. Oh, I did these backwards? Oh. Oh, I did call reduce in that. I was like, why is that not right? Because I didn't call reduce yet. There we go. Okay. So we're also going to need index on this. So we have our character. We have a character that is a a character that is a symbol. So because it's a symbol, what we need to do is we need to now get the numbers around it. Yeah. So the problem is the fact that these are numbers that are here, and yeah, it's because the numbers sum up. I'm gonna do this because I just want to have a clean way to return that. I just want a clean way to do this. So what we're gonna do is we're gonna do const top left is going to be equal to is number, and it's going to be inputs. Actually, I'm going to do const lines. Const chars. Make our life a little bit easier that we don't have to split as much. So if lines line number -1 char at index -1 yes, but we need to make sure that first line number is greater than 0 and index is greater than 0. Okay, and then our top number is going to be the same, but we don't care about index. But we also need to make sure that it's not top left, because if it is top left, it's the same number. And then top right is going to be the exact same, except it's going to be not top. And index is less than chars dot length -1. So there's the 3. You can also do these for the bottom. Same concept. Call it bot. That's gonna be bot left, that's gonna be bot. And then this is gonna be less than lines dot length -1. And this gonna be plus, plus, plus. And now we just need left and right. Left doesn't need to care about the line number. Line number can go away. We just care about index. And so this can just be chars. Actually, we can just do right, and then the right is this. If I spelled it right correctly, that'd be nice. And add. So now we have all of the possible directions which you can do. So what we need to do here is if top left. Now we need to figure out a way to get the numbers. What we're gonna do is we're gonna make a method called readNumber. We're gonna do, oh, that's the wrong place. It's like, why is that wrong? Because it's gonna be here. readNumber. It's going to take in the index. It's also going to take in the line. So what's going to happen is we're going to have a let start is going to equal index start, and then while line, and then while it is a number, line char at start, we're going to go ahead and do start minus minus. It's gonna keep going left until we get the end. And we're gonna do the same thing with the end. Actually, then we're gonna do is once it's not right, we're gonna do plus plus because now we found the end. So end plus plus, but then end minus minus because that's gonna be, actually no, the end's fine because the end will be, it's exclusive anyways. Okay, and so now we're just going to return is going to be a parsint of line substring from start to end. We don't care about that. And but I'm guessing we need to make sure that a number hasn't been read more than once. I don't want to spend so much time on this. We're just going to assume it doesn't. So we're going to have a const typer. We'll get to this in a second. Okay, so read number. What I take this takes in the line. And top left is going to be that. Actually, we're going to do is a subsum here. Equals. And all we're going to keep doing is we're just going to keep doing this. So if top left, good. If top, I could have moved these down here, but it's kind of whatever. Top doesn't care about that. If top right. And then we're going to say left and right. Left is just going to be line. And these are all going to be a plus. And then, oh, this needs to go away. This needs to go here. Did I forget to change these all? Yes, I did. Bots, 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 and oops, no, not there. It was there. And subsum is going there. Okay, and so we're gonna call this const line sum. the other line some. And then const part 1. Let's see how close I am. I'm ignoring the fact there could be multiples. We will see. It's going to run it, but I'm actually going to switch. That's slow. That is very slow. That is not good. Okay. It's not what you want to see. That is not what you want to see at all. Something isn't right. One of these is running forever. Or start is less than 0. Or end is greater than equal to indel line dot length. One of these is messing up. Ah, we're still somehow here. What is start? Oh. Because I did that wrong. Beautiful. Ish. We got not a number. Even better. Okay, how about let's do a console.log on what our substrings are here. Our substrings does isnum work? I feel like isnum is not working. I have a sinking suspicion that my isnum logic doesn't work. Ah, okay. We don't want to talk about that. Yeah, we can not talk about that. Okay. Nothing to see here. Nothing to see here. A period. How did we get just a period? So I need to do this just so I can visually see and make sure there's not. Oops, that goes there. Is there a space at the end? There's not. How do I get just a period? Where does that come from? 35, 663, 617. Where is that coming from? That one random period. 7. 7. One, 2, 3, 4, 5, 6, 7. And the logic all looks right except for that one. There we go. Okay, 4, 3, 6, 1. That's actually correct. That's actually correct now. So what if I go ahead and throw the real input in? I get an answer. But it's not right. Okay, so that's right. Yep, 470. Good. 8. Right. 482. Good. Why do we have 482 twice? Oh. I see my mistake. This logic. Okay, these can't be here. Because I need to know all of them. Okay, so top left is always top left. Top is it's top and not top left. It's top right and not top. Because there were the 3 in a row, it bled over. Left and right are fine, but it's gonna be the same down here. It's bots and not bot left, and bot right and not bots. That's why this way they can't bleed over. And hopefully, if I did this now right, we got the star. Hey, not too bad. Could have been a little better, but not too bad. The engineer finds a missing part and installs it in the engine. As the engine springs to life, you jump in the closed gondola, finally ready to descend into the water source. You don't seem to be going very fast, though. Maybe something is still wrong. First, the gondola has a phone labeled "Help," so you pick it up and the engineer answers. Before you can explain the situation, suggests that you look out the window. There stands the engineer, holding a phone in one hand and waving with the other. You even left the station yet. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is that symbol that's adjacent to exactly 2 part numbers. Its gear ratio is a result of okay. There are 2 gears. The first is in the top left. It has part numbers. Yeah, so its gear ratio is that. The second only adjacent to 1 part number and all the gear ratio. So you get the gear ratio and then we sum up. Okay. Because I don't want to do this. Well, I mean, I for the moment, I don't want it to go through the whole. I don't want to edit parts 1. I just want to do it again. So part 2, we are looking for gears. So if it is a gear, same logic. But this time, we want to read the number in and then multiply. It's not a sum anymore. It's technically a product, but I'll leave it as sum for now. In theory, that's all it should be. I'm going to remove this console log just because it's excessive. And we get 0. Because it starts at 0. Start at 1. It's not correct because there's always a 1. We're always adding 1, which is not right. I think we can get away with some I think I can get away with that. It's not going to change it much, but I think I can get away with that. But I can't, not there. Okay, back test input. Oops. This should be close. Okay, I'll move this up here. Should be close. We should get a number 4, 6, 7. Okay, so it's wrong. Console log. That's the wrong part. Subsum. 4, 3, 6, 1. Huh. Okay. Okay. Let's do this. Remove that. Go to read number. And just console log what the number is. Should only be, okay. So we get that and that. They did something wrong. $617. Oh, it has to be adjacent to 2 part numbers. That's what I'm messing up. Okay. Okay, we're gonna change this up. Okay, let me rename this real quick to subproduct. And I'm gonna need a let count. This we can make it better though. We can do count is greater than or equal to, wait, exactly 2? Exactly 2. Oh my goodness. Okay, that makes it a little bit easier. So now we can just do count plus 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 plus. So that way subproduct, we can just always do it. But now only if we have 2 of these will count be 2, and only then will it correctly do this. Doesn't, 714 seems wrong. Okay. Remove this. Put this here. We're gonna do line. Actually, we're gonna do count with subproduct. Only is greater than 0 because it's the ones I care about. 2. How do we get 714 though? Ah, I did it backwards. That looks about right. Hey, okay. I'll leave that one commented out for right now. So I just changed to input. We'll get an answer now. Please be right so I can be done. Yeah, there we go. Day 3 completed. Give me 1 second to clean this code up just a bit and we'll go over the solution answers. 1 second. Alrighty, so I went through and actually combined both parts into one logic because they were all the same, they were just slightly different logic inside of these if statements here. So I went through, combined them all down to one. reads the number and then just both adds and multiplies them. And then down here, we just kind of return an array of two numbers. That way they're both being bubbled up through the reduces. So only thing I changed, went through and cleaned that up. That way it's just a little bit more condensed, but theory or the solution is still the same for both. So for part one, we are given this nice big long input, and we're looking for cases where we have a symbol that's not a period, a symbol here, and we are looking then to see what numbers are touching it in any of the 8 adjacent locations to it. So to do that, we're going to split the lines split to each individual line. Then we're going to go through each individual line, and we're going to look for a period. I just realized, I condensed these down, but this is slightly different. I just realized that I'm not looking for gears. One moment. Okay, I think I fixed it with this. I guess very lucky that this worked, because I checked these answers when I did it, so I guess I got kind of lucky with this. But anyways, part one. We're going through all of the lines, and we're looking for all of the symbols, which are the not periods. So not periods, and then also not a number. And then what we're doing is, for that symbol, we are getting the top left, top right. We're getting all 8 adjacent squares, and we're checking if there is a number in that square, I'm calling it, or that position. Then what we do is, if there is one, we can go through, we go through each of those checks. So first one is top left. Is there a number in the top left of that symbol? If there is, we call this read number function. And what this read number function does is it basically, you give it the index it starts at. So like in this case, where's the top left? Just like right here. So 627. So it gives it this whole line here, and then tells it to start at this location here, this index. And what it does is it first goes to the left. So it takes the start index and says, while there's another number to the left, we keep moving our start index to the left until we reach like this location where there is not a number, in which case we back it up and we say, all right, the start location is right here. Same thing happens to the right. We start here, and then while there is a number at the right location, we keep bumping our right index up one. In this case, there isn't one, so the right index stays as it is. Here's the logic for the left and the start. Here's the logic for the right and the end. And then because of that, now we have our 2 indexes of the start and end of the number, and we go through, we parse it. I don't know if this is totally necessary. I went through and made sure that we don't count a number twice. I don't we don't count a number twice. Don't know if it's needed, but I have it here. That's what this is doing. And then, assuming it's not been counted already, we return the number. If it has been counted, we return 0. And then what happens is, after the number is read in, we add it to our rolling sum for part 1. Part 2, we add it to our rolling product, and also increment count, which is off of part 2, so we'll get to that in a second. But part 1, we add to our sum. Then we go through and we check all the other 7 locations. Because top here, so 766 here, because we have a 6 here, we've already counted this 6 in 766 because we've already checked the top left location. So to avoid checking it again, we simply check that there is a number at the top location, and there's also not a number at the top left, because there's a number at the top left, we've already counted it. If there is a number at the top left, we do the exact same thing to get the number that's above, but if there is one there, we skip it. Same thing the top right. Top right, if there's a number above it, or if there's a number at the top location, we skip it because again we've already counted it. And then again continue on left, right, and bottom. All the same logic. Check to make sure we haven't already counted this number. If we haven't, read the number, add to the sum and product and whatnot. And then all this is doing though is now just bubbling up our sums for all the lines, and then for the whole thing, or I guess this is for all of the symbols, and then for all the lines, and then at the end we get our part 1 answer. Part 2, identical. You can see here, when we get that number, we simply add it to the product. We also increment this count variable here because we need to make sure that there's exactly 2 numbers that are adjacent to a gear, which is this symbol. If there are, we go ahead and add this product to a rolling sum. If not, we don't add anything, so the sum stays as it is. And so this is going to sum up all of the gears in a line. This sums up all of the lines together, and that will give us part 2. There we go. Hopefully that was a decent explanation that made sense, but overall not too bad. But 3 days done, 22 more to go. So thank you guys all for being here. I'll see you guys all tomorrow for day 4. Peace out.